let's jump in. Before I go a little further, we've seen quite a few ionic formulas named, and I want to make an emphasis here. Spelling counts. Look at what a single letter or two can do. Chloride is Cl, chlorate is ClO3, chlorite is ClO2. All of these have very different properties associated with them. They're all salts, they're all ionic compounds, but they are different ionic compounds. And so you have to be very clear in your spelling. Now, the last little topic of ionic compounds that we want to cover are our hydrates. Now, hydrates are ionic compounds that tend to trap water, right? If you're dehydrated, you drink water. So that word hydrate implies water. And there are many of them that trap them in their crystal structure. And we can heat them and cause, it is a chemical change because the colors are quite different. For example, copper 2 sulfate pentahydrate's beautiful blue, but copper 2 sulfate is more of a white, almost a white gray. Now, when we do gently heat off the water, we would call that the anhydrate, an meaning without. So we have hydrates with water, anhydrates without water. Now, how we distinguish those is we use a dot in between the ionic formula and the waters to tell how many waters are present in the formula. Now, these are the same prefixes that we're about to use in our covalent naming. Be very careful because once you start using these prefixes, you want to use them in ionic names and you can't. The only time we're going to use these for now are to tell the number of waters in a hydrate and when we're dealing with covalent substances. So let's take a look. Here I've got Cu2SO3. There's that dot. Remember I said we use a dot to tell you that those waters are tightly bound and trapped in the crystal structure. Now, since the sulfite is -2 and it takes 2 coppers, so I need +2 to balance out that sulfite, 2 coppers give me +2. So each copper is +1. I indicate that with the Roman numeral 1. Now there's 3 waters. The prefix for 3 is tri, and I use the word hydrate to name those waters. So that's copper 1 sulfite trihydrate. Now sodium only has 1 oxidation number. It's group 1. It's always +1. So there's no need for Roman numerals. Before you walk away from naming an ionic substance, you may want to double check that. Just ask yourself, man, do I need Roman numerals? Now, this is sodium sulfate, but I have 10 waters. So I use the word hydrate to tell me that I have waters bound to it, and the prefix for 10 is deca. So it's sodium sulfate decahydrate. The next one is lithium nitrate. If you don't know your polyatomics, it's going to be challenging by the end of this unit. You will have a quiz on polyatomics. Check your calendar. There are 3 waters, so I put tri for 3 and indicate the bound waters with the word hydrate. Okay. Now, to go in the opposite direction, I simply write my formula like I did before. I have cobalt. That Roman numeral tells me it's the +2 oxidation. Fluoride, IDE, is the negative anion, F-. Tetra stands for 4, and hydrate indicates waters. So that's how I take those words and put them into symbols, which is what a lot of chemistry is. So lowest whole number ratio between the cobalt and the fluoride is COF2. I put a good sized dot there to indicate that I've got bound waters, and then it's 4H2O. Okay, I'm going to go ahead and move into covalent molecules because they're very, very straightforward. All we do on covalent when it's 2 nonmetals, and so we're talking about binary covalent right now, 2 different nonmetals to be covalent, and we use prefixes. And it just tells us there's no algebra, there's no least common multiple, there's nothing in terms of any kind of calculation or manipulation. The prefix tells us how many there are. Now, the only time we don't include a prefix is if it's mono on the first element. We don't use mono. We use mono on the second. So carbon monoxide, we still use the mono, and you notice that there's a little smoothing out of vowels in there. There's a statement in your notes about that. We just wouldn't say monocarbon. So the only time we don't use a prefix is on the first element when there's only one of the first element. So here I have one carbon. It's not monocarbon, right? We don't do that on the first element. There's two oxygens, so it's di, and just like we did with the ionic, we changed the second one to an IDE ending. The first one gets to keep its full first name. The second one has a change in its name. Now, this next one, I have two nitrogens. You can't drop it if it's a 2. You don't drop the dis, you only drop the monos. So it's dinitrogen. Notice it's the full first name for nitrogen. And then there are 3 oxides. Remember, we change oxygen to oxide, trioxide. So it's dinitrogen trioxide. It's not monosulfur, it's just sulfur. We drop mono on the first element only. There are 3 oxygens. We use the tri. Instead of oxygen on the second element, we change it to IDE. Okay, so let's take a look here. Dinitrogen tells me I have 2 nitrogens. Pentoxide tells me I have 5 oxygens. There's no, crisscrossing, figuring out charge balance. That prefix tells you how many of the element that follows are present in the formula. So I have chlorine, only 1. Monofluoride, 1 fluoride. Okay. Nitrogen, fluoride, and there's 3 of them. So there's 1 nitrogen implied. I wouldn't have bothered writing nitrogen if I didn't have at least 1 of them. And then fluoride is a 3. So, covalent you usually grasp pretty well. The difficulty that you're going to see is it's going to be such a temptation to use these prefixes in your ionic compounds. But remember, prefixes only on hydrates, and just to tell you how many hydrates, and on your binary covalents. All right, we will do acids next because they are pretty tricky. So until then, this is signing off.